Hello, my name is Professor Adrian, and this is episode 15 of the Quadratic series where we're going to be looking at properties and forms of a parabola. If you find this video helpful, go ahead and drop a like. If you have any questions throughout the video, feel free to comment and consider subscribing for more math lessons. With that out of the way, let's take a look at what we're going to be talking about specifically in this video. We're going to define and identify things like x and y intercepts, the vertex, axis of symmetry, what it means for a parabola to be stretched or compressed. We're also going to look at the different forms, standard, vertex, and factored form, and define domain and range for a parabola. We're not going to do any math specifically in this video. The next few videos will cover how to graph in each of the forms explicitly. So a parabola is a graph of a quadratic. It's going to be a curve that goes down and then curves and goes up, or it might go up and curve and come down. So it could look really two different ways. It could look something like this, where we go down, curve, and go back up. Or it could be upside down and open up the other way. There are a number of properties to look at with a parabola depending on how it looks. We have the point where it makes its turn. Right here, where it changes from decreasing to increasing, or it changes from increasing to decreasing. This point is called a vertex. Through the vertex, there is a vertical line. It's kind of an imaginary line. It doesn't really exist. But this imaginary line is a line of symmetry. It is symmetrical, the parabola is symmetrical across this vertical line. So we call this vertical line an axis of symmetry. An axis of symmetry is in the form x equals whatever the x value of the vertex is. We have a y-intercept, so let me draw another parabola. Let me draw a better one. All right, we know we have the vertex, we know we have the axis of symmetry. There is a point, one point, and only one point, where this parabola crosses the y-axis. That point will be the y-intercept. Every parabola will have a y-intercept, just like every parabola will have a vertex and an axis of symmetry. However, parabolas can have 0, 1, or 2 x-intercepts. So this parabola that I've drawn here crosses the x-axis in two spots. So we'll call these the x-intercepts. A parabola like the two that I drew at first, they don't cross the x-intercept, or they don't cross the x-axis at all, so there is no x-intercepts. And then we have a third case where a parabola might be on top of the x-axis. Its vertex might be on top of the x-axis. And if that's the case, the vertex is also the single x-intercept. Parabolas can also be stretched and compressed. What I mean by this is if we have this parabola in black, it can be stretched vertically meaning it's going to get skinny. It's going to get more narrow. It can get compressed vertically, meaning it's going to get wider. So this wider one we called compressed. Vertically, because if I had like my hand and I could push down on this black parabola vertically, it would push it down and open it up. If I could stretch it vertically and grab onto this and pull it up, it would make it skinnier. So we call this stretched vertically. What about horizontally though? If I took the black parabola and I grabbed it on either side and I stretched it apart, it would look like this blue parabola. So I could also describe this blue parabola as being stretched horizontally. Likewise, if I took the black parabola and pushed it together, compressing it, it would look like the red parabola. So I could call this red parabola compressed horizontally. So you need to be careful when describing what's happening to a parabola using the word stretched and compressed, and make sure that you're including the proper term horizontally or vertically, because compressed horizontally is the same thing as stretched vertically, and stretched horizontally is the same thing as compressed vertically. Okay, and next I want to talk about domain and range. Domain, we should remember, is all of the x values that we can input into a function and get a real y value solution. So what x values can we put in? Graphically, we can look at the x-axis, and anytime I'm on the x-axis, if I'm here, if I can go up and touch the graph, that means this x point is part of the domain. If I pick another x point, I can go down. I'm on the graph, so this x point is on the domain. If we look carefully at our arrows, we see that these are going off at an angle all the way to the left and all the way up. This is going off at an angle all the way up and all the way to the right. So it's going to take some time to get all the way over to, say, here on the x-axis. We're going to be very high up, but we're still going to get there. Likewise, going all the way over here is going to take some time. We're going to be very high up, but we're still going to get there. Because of this, the domain of every parabola, it doesn't matter if it's been stretched or compressed, or if it's facing up, if it's opening up like this, or if it's like one from the first slide where it's opening down, the domain is always all real numbers. We can also write this as negative infinity to infinity. The range, on the other hand, is dependent on which way the arrows are facing. If the arrows are facing up like this, meaning our parabola is opening up, then we know that we are going to go up and up and up forever. So we're going to go all the way to infinity, but where's the lowest part of the range? The lowest part is actually at the vertex. So whatever the vertex is, specifically the y value, will tell us what the lowest point of the range is. If this parabola was upside down, our range would go all the way down, 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 down to negative infinity, and we would go up give you a visual representation, and we would go up and up and up until we hit the vertex, and that vertex would be the highest point. So whatever the y value of the vertex is, that would be our highest point in the range. So domain of parabolas, all real numbers, negative infinity to infinity. The range is going to be from the y value of the vertex to infinity, or from negative infinity to the y value of the vertex, depending on which way the parabola is opening, if it's opening up or if it's opening down. So to recap, we have the vertex. This is the bottom or the top of the parabola. It's where it changes from increasing to decreasing, vice versa, from decreasing to increasing. The vertex, probably the most important point on the entire parabola. The y-intercept, there is always a y-intercept. Even if you can't see it on your graph and your calculator, there is always a y-intercept. The x-intercept, there can be 0, 1, or 2. There is always 0, 1, or 2 x-intercepts. The axis of symmetry is x equals the x value of the vertex. Stretching and compressing, remember that stretching horizontally is the same thing as compressing vertically, and stretching vertically is the same thing as compressing horizontally. I would pick one of these two ways that you want to describe something, either by vertical stretching and compressing or horizontal stretching and compressing, and stick to it. The domain is always all real numbers, negative infinity to infinity. The range depends on the vertex. It's either negative infinity to the y value of the vertex, or the y value of the vertex to positive infinity, depending on if the graph is going up or down. Okay, so the purpose of this video was to get to this point where we are familiar, at least a little bit, with this sort of vocab, so that in the next few videos we can look at how to specifically graph things in the various forms. If this video was helpful, please consider giving it a like so that I know to keep making them. Comment if you still have any questions, or if you have a suggestion for something that you would like to see me make a video on, and consider subscribing for more math lessons. Thank you, and we'll see you in the next one.